All right, ladies and gentlemen, welcome back once again to the longest running show in the world about data. It's called DMRadio. Yours truly, Eric Kavanagh, here with the cloud legend himself, a man who's probably forgotten more about cloud than most of us will ever know, David Linthicum. And we're going to talk about not necessarily just cloud, but agentic AI, the hottest topic since sliced bread was invented back in many thousands of years ago. Everybody's talking about agentic AI. Is it more than RPA? Is it more than IPA, intelligent process automation? Yeah, it is. And I'm just going to throw out my first couple of comments here. David, I've been researching this a lot, talking to a lot of smart people. And we were joking before the call that I think you said there's a Grand Canyon between where the hype is on agentic AI and where the reality is on the other side. And that's a pretty big canyon. Even Evil Knievel wouldn't want to fly across that canyon or that canyon in his motorcycle. But the one thing that really struck me and I find very interesting is this beliefs, desires, and intentions model, where the agent has beliefs, which is basically a data set of what it thinks is the case. Like I would just presume, data quality should be at 95% or higher for this data set, for example. And then desires, what do you want to do? Intentions, what are your plans? And that kind of makes sense to me. I can see how a little autonomous agent could have this worldview and have these basic setups of parameters essentially, and then go out and execute stuff and call on things and grab data and analyze data and do stuff. But you got to be able to track all that. You have to be able to know, all right, what are the beliefs? Are they shifting? What are the intentions? What's the plan? I guess that's a bunch of log files. That's kind of what I'm hearing. But what are your thoughts about agentic AI? And are you hearing about this beliefs, desires, and intention stuff?
Yeah, everything and anything everybody's attributing to this. So at the end of the day, these are autonomous agents that have their own persona. We're able to give them goals and objectives. We're able to give them priorities. We're able to give them personalities. We're able to give them a set of things that we want them to do intentionally and carry out an action. Now, the idea is if we have one, it's going to carry out a specific behavior via persona. We can have many others, hundreds of others in many instances where there's a coordinated combination, where they're dealing with data, where they're dealing with business processes, dealing with supply chain integration, whatever business problems that are there. So your ability to kind of set them up with a priority, I think, is going to be an important thing because in essence, it's going to operate independent unto itself. But you have to remember it's a knowledge model. And so the model can change over time. So its behavior is going to change based on the experiences that it runs into, based on the outside stimulus that it has. And so, really, when you look at the common function of an agentic an AI agent, it's really kind of dumb. In other words, it just carries out pre-programmed work and learns as it goes. And you have to remember that it's only going to know what it's trained to do, and it's only going to know what the priorities that are there. It's only going to know what it's been taught to follow. And people have a hard time kind of understanding that. So if we're building an agentic system, I built a few of those. You'll see the agents take on an action that isn't necessarily desirable for the purpose in the system. And we'll even see agents that will take on an action that will evolve to it. In other words, it evolved into a bad action and did something that we didn't want it to do. So the struggle comes in, how do you program the thing to carry out everything that he wanted to do with data, data quality, things like that? And then how do you manage those things longer term? And then it becomes kind of a governance challenge. And I think that's why we talked about, before we went on the air, I'm just seeing a huge amount of hype versus the execution. And when I do see the execution, I think enterprises are struggling with that. In other
Mm.
words, your ability to, in essence, provide the capabilities within the agents that are going to not morph into areas where you don't want them to morph in. So it's funny, you see a collection of a multi-agent system. Everybody has programmed desires, intentions, outcomes, goals and objectives that they want the things to do. That'll change over time unless you specifically program the agents not to do that. And as soon as it
Right.
changes, everything falls apart because you got to remember these things are interrelated one to another, they're communicating one to another. Each carries out a particular role. If someone doesn't do their role and responsibility correctly, then they're going to have an issue with the agent. Therefore, they're going to have an issue with the system. It becomes unreliable. And I think the complexity of this is where people are killing themselves right now. They
Mm.
understand what it is. It's very cool. It's very cool to talk about it like we're doing now. But executing it is kind of another, set of problems.
Yeah, and this is my big concern is governance, especially governance at scale. One of the smartest guys I've come across around here in Pittsburgh, Lou Simon, he was telling me, gosh, like 8, 9 months ago, he goes, these things can do damage. If you start unleashing these things in your environment, they'll do things that you didn't expect. It's like, I mean, it is kind of like giving interns keys to the castle and expecting that no bad things will happen. And they open the wrong door and they turn off the hot water and they do all sorts of different things that cause disruption. Well, again, what do the guardrails look like and how flexible can the guardrails be? I see companies like Boomi working on a control tower, which makes a lot of sense to me. Like you want to have some kind of orchestration mechanism that is tracking what they're doing, making sure they're doing things correctly. That they're not saying, "Hey, stop doing that." If data quality is going down after you deploy these guys, there's a problem. And then there's this other aspect of an LLM, which is not the same thing as an agent. Now, agents can use LLMs, and that can get pretty interesting because they can just ping an LLM. How do I connect to this API? I'm told that's something they are doing pretty well. It's like connecting to APIs and kind of handling basic blocking and tackling stuff. But the problem with the LLMs is that they are very unwieldy, and the term I came up with is capricious, right? Like, because they will change things that you weren't asking them to change. Like a buddy of mine is telling me they change port numbers on all these execution processes, and he's like, "No, don't do that. Stop changing the ports because I can't control this." So they're very capricious. The LLMs are. The point is, you have to have a workflow that you can define and monitor and govern if this stuff is going to work, and that remains elusive, right?
It does, but like I point out in my Augentic AI architecture course out on LinkedIn, is there's different architectural patterns that people can leverage. And there's going to be a peer-to-peer pattern that typically people use where there is not going to be one common supervisor. Everybody works together and they become a system unto itself, just doing peer-to-peer interaction with multiple agents. But the supervisor-based agent use of the system, I think, is the single most easiest way to do it. And that's, in other words, you're going to have a bunch of agents that are carrying out an action, but you're going to have a master agent that's able to coordinate the interaction of the systems and the ability to orchestrate what these agents are able to do. I always advise my students that that's typically going to be the way you need to go, and it needs to prove itself as not going to be desirable to go to this peer-to-peer stuff because we are going to get the problems that you just mentioned. These things are going to develop a life on their own, and they could go rogue. Remember the worm that was created by Kevin Mitnick back in the 80s where it was basically took off and started to do lots of things that were bad actors. That kind of stuff is possible with this stuff unless you're key on keeping the programming, keeping the governance, keeping the security down, and not necessarily monitoring. So you have to have some sort of a master control system, and you have to have some sort of a way that's going to monitor what these things are doing, is able to establish some sort of a pattern. These things are reporting back based on their execution. In essence, they become the core functions of a system. The way I like to describe it, this is going to be agents that are pieces of software that are really should be in line to programming systems. In other words, even though they're in different operating systems, different processor spaces, things like that, they have their own knowledge models. We're operating them as if they're the same monolithic program. And that's the way we should think about it. We have people too wrapped up in the whole agentic stuff and the agent stuff. And the reality is it has to carry out some sort of business interaction. Typically, those business interaction is going to be part of the domain. So we're going to operate these agents within that domain, not necessarily separate them out. And so
Hmm.
if you're doing that, then I think you're going to be okay in establishing the patterns that the agents are going to be leveraging. So, they're going to be leveraging each other and leveraging some sort of a common control mechanism that organizes how they're carrying out whatever business process we're looking to do. The LLM thing is kind of a unique thing. You got to remember, you can make an LLM an agent. I don't know why you would do it. You can also, put SAP in a container. Just because you can doesn't mean you should. Um, so the ability to leverage these systems as remote capabilities is going to be core to this. Because remember, everyone wants to build their own LLM. That's not necessarily needed. So when they need LLM-based services, they can call any of 150 LLM-based APIs, do so rather quickly. and even have an agent control interaction with those LLMs as possible as well. So everything and anything is on the table with this stuff,
Hmm.
but you get overly complex and over engineering very quickly with this stuff. If I'm reviewing agentic AI systems where they're running into issues, it's always going to be a matter of them over engineering, over complexifying these various
Interesting.
agents. They get in trouble.
Right. Yeah, you bring up an excellent point here. It's like, bringing a nuclear bomb to kill an ant at a certain point. You don't need that much power. And these LLMs are not all that good at reasoning. In fact, some people tell me they don't do reasoning at all, really. They're just pattern matching when you get right down to it. Now, I think what's happening is you're getting layers like fine tuning built into Anthropic and OpenAI and all these guys. They're trying to sort of tame the shrew, if you will. And what I think is interesting, and this is a bit of a turn in the conversation, but I'm curious to hear your thoughts on this. Yeah, I realized a few weeks ago before a show like this, I kept thinking about where we've come from, where we're going in computing and in information systems. And for the history of information systems, we've had some basic principles. Number one, the database is the foundation. You build applications on top of it. And in the database, we've spent half a century now improving the performance, improving its ability to have concurrent users, to connect to systems. But the accuracy was never in doubt. You would always get out of it what you put into it. No questions asked. It was table stakes. Of course you do that. Now Gen AI comes along and it's like throwing a noise filter on the end of this pristine workflow that we spent 50 years perfecting. It's like, well, why would you do that? And of course it's because it has this amazing ability to spin up natural language, and it sounds so real, and it does a really good job with lots of different topics. I mean, they are getting really good, but you can't tell where the errors are. That's the problem. And so I'm like, oh, look what just happened. We spent 50 years on this trajectory getting faster and better and more performance and better price performance, and then this LLM stuff comes along and just throws everything cattywampus. And now we're in sort of a rear guard strategy. Like, how do we contain this thing? How do we ground it with a vector database, with a knowledge graph, all these other ways to kind of pull it down to earth to where it's not just making stuff up? I think that's a fascinating inflection point. What do you think?
No, I think you got something there. And I think that, well, number one, are you asserting that LLMs actually make mistakes, Eric? Is that something really? Yeah, absolutely. It's a big issue. So ultimately, you have to look at what the value these things are going to be able to provide. They're going to provide sets of responses based on massive amounts of data and the ability to do inferences on what that data is out through a learning process. That's all cool and happy to do that. But you got to have the ability to kind of double check some of the inferences and how they're occurring. Now, one of the good things that I do see happening out there is that we're not necessarily always relying on LLMs as the core answer that we're getting from some of the stuff. So it's integrated with the business system. We're dealing with our small language models that are built using our own tactical data, and we're using the LLMs to verify things. In other words, they're verifying economic trends, they're verifying logistics optimizations, things like that. And that's what LLMs are very good at doing. But we're assuming those answers are going to be suspect when we do that. And so the first thing we do is we verify that against the patterns in the data that we currently have. So now we're verifying our own tactical knowledge with the knowledges that are coming out of the LLMs. So, and it's weird, we're at a point where we have to double check and triple check, information that's coming out of these various systems. Like, well, is that a step forward?
Right.
What am I doing now? But if you're going to use that technology, you're going to have to build it. And the other thing we can do, and I've been saying this for a while, you don't necessarily need to integrate an LLM into your system. And so, in other words, it has its own drawbacks and its own purposes. But I see people kind of force fitting these things, if, foundational model, things like that, unless they're going to have some sort of a strategic benefit in using the system, they're typically
Right.
not going to be needed. You can use business analytics, which is perfectly fine, which is able to give you information that's going to be truthful. In other words, you're leveraging data, at the state that the data is. And so the overuse of generative AI for all these kind of odd applications is not going to lead in a good direction. You're going to increase the expense and complexity of the application. It's about 5 times the cost to build something using a generative AI system. And I
Hmm.
know that I'm running a generative AI architecture course right now. So you have to be very careful in terms of how you're applying them. And when you do apply them, you have to understand that the information that comes out of them is not like a database. You have to be
Right.
suspicious about it, and you have to use it in the context of other data that you can validate that the data coming out of the LLM and the results coming out of the LLM are going to be truly efficient.
Yeah, and that is the key right there. You just said it. You have to be suspect. So you have to use it in the proper context. When we were at the Confluent event last October, their chief research officer was telling us point blank, he said, look, I'll be honest, all of the production use cases that we've seen so far are inwardly focused. They are decision support, meaning there's a human being in the company absorbing this information and determining whether or not to use it. It's not outwardly facing like customer service, for example. And you can see why there would be a desire to use, and I remember when chatbots first really kind of came out. It's a long time ago now. It's like over a decade ago when the first chatbots came out, and they did not do very well. But my theory was that they arrived because search sucked. I mean, like enterprise search. When you go to a website, let's say 10 years ago, and some corporation, you want to search for something, you would get absolute crap results. I mean, just horrible stuff, like boring press releases that have nothing to do with what I'm trying to find. And I remember I actually talked to a girl who, as it turns out, was working at Google back when they were pushing that whole search appliance. And she laughed about that. She goes, yeah, we had some trouble with that. It wasn't working so well. And that's kind of what Copilot and ChatGPT have become now. I mean, I've been playing around, and we got a break coming up here in a second. But I've been playing around, and you'll get better responses on queries about what's happening in the world from ChatGPT than you do from Google these days. I mean, Google, you can feel it. They are stumbling. They pivoted to agentic response. You can tell they have some sort of a sniffer on there that determines, okay, should I go with just links like I used to, or should I generate an answer? And they're working on that, but it's not as good as ChatGPT. When I ask ChatGPT, I get very crystal clear answers, even if like you have to sense which one is wrong somewhere in there, and that does happen. Nonetheless, it's like, I mean, you want to talk about a tectonic shift. People have just come to expect that Google would give you the answer. Like, Google it, go find some information. You go into Google, put your query in, get a whole bunch of links, sort through. Of course, you have to get by all the ads first. Now there are like 13 ads before you get to the first organic response. And I've heard from a very smart person that even the organic responses aren't really organic anymore. And I've done some testing on this, and I've come to conclude that YouTube and Google are largely pay to play platforms when you get right down to brass tacks. And it's like, why wouldn't they be? It's not like they came out and said, hey, here's this public service. We're going to help you all out. That's not what they did. But folks, don't touch that down. I'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio with the legendary David Linthicum. So I was mentioning before, I know we talked about agentic AI, but LLMs, of course, are all the rage. And as I'm suggesting, Google, I mean, wow. Gemini, not as good as ChatGPT, not as good as Claude. Google Search, not as good anymore. Like, where are those folks going? What's your take on the state of Google right now?
I don't Google anything anymore, other than maybe trying to figure out if there's the hours of a local pharmacy, something where I have to have some real kind of a tactical need to do it. And so I'm just like you. I'm out on ChatGPT, all the time to do my research. They can give me the links, and my responses that come back for the inference engine are traceable, down to where
Right.
they came from. So how do you beat that? And also, you're able to, write a draft outline in terms of what this article could do that I just researched, and the ability to look at is there any kind of compelling issues that are out there, that would be higher ranked that would provide different, different levels of SEO, and they can tell me that. And so you can kind of up your game in a very short amount of time. So there's no reason not to do it. So I weaponized that a long time ago because it is a force multiplier for the thought leaders out there. And I think a lot of people are even able to get a lot of thoughts and thinking and find information they normally wouldn't be able to find. My content has gotten a lot better because I'm able to go a lot deeper into these various things because I'm not just remembering what I remember or what Google tells me. I'm looking at every aspect of a particular concept or topic for the most part
Right.
and understanding the details behind it.
Right. That's what I'm discovering. The perfect word is force multiplier. You can, with these tools, explore so many different angles. You can, I mean, the other elephant in the room here is higher education. You look at what's happening right now with Harvard, for example, a $53 billion endowment. The feds are threatening to take away their tax exempt status. Like all kind of crazy stuff is happening. And it's like, when I can just sit here in my living room or my basement and queue up any topic that has been published about in the world that these models have absorbed and learn 80 to 90% of what I need to know, even if 5 to 10% is wrong, right? I mean, out of the box, these large language models make probably 80% accuracy, but I think they are getting better. But your teachers were wrong about some stuff too. Textbooks have been wrong. What's the old joke about history? It's amazing how the good guys always won, right? And whoever wrote the history books, that is a huge, deeply disruptive reality. And what I think is fascinating is that anyone who has the interest and invests the time can learn about just about anything. I mean, I've been using it to understand POSIX file systems and how you get access to things. I've been researching for this fascinating company, Hammerspace, I've been doing some work with, and Tier Zero storage. And it's like you can just sit there all day and go deeper and deeper and deeper in whatever you want. That is tremendously disruptive and transformative, right?
Yeah, and you go down into a rabbit hole on some of this stuff, but you're able to go down to an efficient rabbit hole. I spent all my time trying to cull through data to see what was relevant and what wasn't, and I even had to do some validations of the links and where the data came from, and researching various things. So just amazingly powerful stuff. And we also have the ability not only have the NLP stuff, the natural language processing, but the ability to access this stuff via APIs for utilization of various systems. So they're backing up a lot of this stuff and provides a lot of value directly from those LLMs using any number of ways.
Yeah, I love this. A very efficient rabbit hole. That's pretty good. Well, even, and I know that when you read the requirements or the terms of service for ChatGPT, it says do not use this for healthcare, do not use this for like anything important, basically the classic disclaimer. Like on your lighter, it says, "Oh, this is going to light a fire." Like I know, that's why I bought a lighter, right? I mean, like how much guarding do you need against reality? But I know it says that. But think about it. Now, any doctor can research any condition and get all sorts of information. Now, again, you have to make a decision as a doctor about what information you collect, but you can diagnose most like my wife had a little thing on her arm, a little skin something. We didn't know what it was. Purpura, I think is what it's called, and we like looked it up, and sure enough, like that turns out to be what it was, and it's like just say the visit to the doctor's office because now you have to be careful. But still, like all this information, it's like a dynamic Encyclopedia Britannica that you can just spin up and explore at your leisure and go down efficient rabbit holes, right?
Yeah, and it's where you can solve problems instantaneously. I'm rebuilding a mountain bike. I had to figure out the torque, the torque for the crankset for the particular model that I was having. I put in the brand, the crankset, the model of the frame, crankset I was using. They told me the exact torque rating that came out, and it's going to be, probably 90% right, but who cares if I over torque something, because it tells me that's fine. Try Googling that. You're going to find any number of pages. It's all over the place in terms of what torque settings are telling you. So
Right,
you're able to nail down onto a response that's probably correct. Okay.
right.
And that doesn't matter if it's a medical diagnosis, it doesn't matter if you're, dealing with a mechanical issue, you're dealing with a computer problem, but you're also able to go deeper and deeper and deeper. So in other words, how do I do this particular thing with a computer system? And by the way, what is it? How do we describe what are the typical requirements? By the way, write the code and it'll take care of it for you
Right.
just to get to initial prototype. By the way, do it in all of 30 minutes, versus taking a couple of days to figure that stuff out. So it just provides smart people with the ability to move faster, which I think is going to make us better.
Well, and so one of my best friends is a developer. He's worked for some of the biggest names in the business. He's very, very good at what he does. And he was joking with me that his girlfriend, who knows nothing about coding, was able to build a performant website, an e-commerce site in 2 days that the company's team of developers in Pakistan spent 6 weeks building incorrectly. And she was using, I think, Bolt.new and a couple of these other systems that generated API connections, a schema, data model, just spun it all up. I mean, the folks from OutSystems are doing this with a Mentor, where you load in a requirements document and it builds the freaking app for you, and you're like, oh, what? I mean, that is a fast track to innovation. That is, again, tremendously disruptive, but very productive for the people who use it properly, right?
It's absolutely productive for the people who use it properly. And I don't view it as something as replacing some of the engineers and developers out there. They're just going to be able to sit in the
Right.
driver's seat and how they're setting these things up. So it's going to make them much more effective at their jobs. And they're able to get down to any API level system that they need to validate that it's typically going to be right. It should be a fewer errors we're making, and I think that's it's going to benefit everybody. Developers, I think we haven't seen nothing yet. They're going to kind of take their jobs to the next level.
Yeah, I think that's exactly right. And that's how this should be viewed as another tool in the toolbox, a tremendously powerful tool. But you do have to watch out, like fine tuning, for example, and I should be careful about that term choice. Like when you're working with one of these engines to get images, we found it's great at giving you very creative images, but it's not so good at taking precise granular instruction. Okay, now make this text bigger and that smaller. It doesn't do that so well, but it is excellent for prototyping. It's excellent for getting the ball rolling and then handing it off to a person like a developer to finish the job. Well, folks, look this gentleman up online, David Linthicum. Like I say, he's an expert in cloud. He's got classes on there. He's got all kinds of useful information. We'll have him back on the show shortly for sure. And send me an email if you want to be on the show, info@dmradio.biz. You're listening to DM Radio. All right, back here on DM Radio, folks, talking all about the cloud, agentic AI, LLMs. It's always fun talking to David Linthicum because the guy knows so much and he's got a very practical mind. He has built solutions, he's built systems, he's done massive cloud integrations over the past 20 plus years, quite frankly. And I want to dive into what he said there a few minutes ago, a very efficient rabbit hole. Like, wow, that is really a fantastic metaphor. Of course, typically you think of a rabbit hole as wasted time. Like you just go down some rabbit hole and you sort of lose perspective. You're trying to find something, but you realize it's just kind of going down and down into a rabbit hole. But it could be a very efficient rabbit hole these days with these large language models because they have consumed so much information. It's really remarkable. And, I'm reminded of how they actually operate, or at least at a high conceptual level. And the big aha moment for me was, I guess, about a year and a half ago, maybe, when I realized that as you train a large language model, you're not persisting text strings per se, which is what you do in a database or a traditional information system. You capture specific strings of text and you store them in a field. And then you call it up and you get back what you put into it. It's a very standard operating procedure for databases. But an LLM is not really a database. It is a deep learning module, and it can have any number of layers. I mean, that's the thing people need to understand about these deep learning systems, and they're not new. We've had deep learning, gosh, for decades now, but they are very sophisticated, and in fact, in part because of Craig Schmidhuber, I'm sorry, Jürgen Schmidhuber, who wrote the papers on the Transformers back in 1990 and 1991. Now we have these incredibly powerful systems, and by and large, they have been trained on vast troves of data. Well, again, you don't persist the text in some field somewhere in the LLM. What you're doing is you're adjusting the weights and the balances of the parameters of the model. And that's a very different ball game than what we've been used to over the years. So you have to use these things in an appropriate context, and that's what David was talking about. Be careful about the outputs because you don't know for sure that they are real. But I will say that from my judgment and from my research, they are getting pretty darn good. And for anything that's been widely published about on the interwebs, they're going to be pretty accurate in nailing things down. Now, the problem is that you don't know where the mistakes are, and they sound so convincing. They write in elegant prose, it's syntactically correct. They have good vocabulary, of course, because they know all these words from their training. They've been trained. And remember, the words in a traditional vector database or a vector based system, which is what these LLMs typically are, the words are just vectors. So they are mathematical constructs. It's a point and a line in a certain trajectory for a certain distance. And then you basically cobble those together, or the LLM does, upon receiving a prompt. It's amazing. what you can get, but you have to be careful with it. So that's why I was saying most of the systems these days are internally focused. They are a co-pilot. But let's get back to that highly efficient rabbit hole as a learning tool. They are incredibly valuable because you can get deeper and deeper into any subject you want. And again, as long as it's been widely published, it's going to be pretty accurate. Now, it may get certain details wrong. You have to watch out for it. And you got to watch out for how you put it into production. So, my good buddy Eve Molkers of 7W Data, he's been playing around with these things for over a year now. And what he has learned is that the LLMs are downright capricious. Do not put them in charge of maintaining important details of your config, for example, because they will make changes to configuration code, which can break systems. That's why you got to be careful about this stuff. So don't put it in charge of anything really important in your company. Use it as a co-pilot. As a co-pilot, it is tremendously powerful. And as David was discussing, and I've seen myself, Google search is falling apart. I mean, goodness gracious, I can't believe like how bad it's become in terms of finding basic stuff. And I think that there are lots of reasons for that. One reason is because of their response to ChatGPT, which is to take more of this LLM oriented approach in delivering answers. But again, you will find it. It just gets information wrong. It just does not report accurately what's happening. And sometimes the mistakes are glaring. I remember when I used Google to search up the number of bankruptcies year over year, and it said that, oh, 2024, there were 34 bankruptcies. I'm like, I think it's more than that. I think there's more than 34. So the numbers can be just wackadoodle wrong. I mean, just like not even remotely close. And you see this in the image generation too. So I used Gemini the other day to create an image for a document to promote our company. And it's funny what it came up with. It's just bizarre. Instead of the Blur group, it was like the Blur, the Blur as a number. I was like, what? What are you talking about? That shows you how complex the systems are that are generating this content. They are highly complex. And in fact, the smartest people, and you'll hear this on these shows that we do, the smartest people in the industry will tell you they don't know how these things work. So now, like for the first time ever, we've kind of created these powerful engines that we're trying to now tame and harness and even unwind to a certain extent. What does that mean? I mean, good question. Be real careful about how you use this stuff in production. That's the key is be careful how you use these things because they are very unwieldy. And it's the term I came up with is capricious. And I think that's a pretty accurate term for how these things behave because as many of you may have noticed, if you use them often, sometimes they'll answer questions very quickly, very easily, and sometimes they just don't. Sometimes they're way off. They get crazy responses. You're like, what on earth is going on there? It's almost like a poor person who has dementia or is genuinely losing their mind. They can just start rambling and speaking in tongues, seemingly. And that's what you're going to get with some of these things. So, it behooves us all to pay very close attention to what is going on here. And again, focus on the architecture of what we're building. I suggest use these things as co pilots, use them as research agents. They are incredibly powerful. Be sure to cite your sources, check the sources. One of the things I read the other day about using them in production is they will just invent new libraries. They'll say, "Oh yeah, use this library, that library." There's no such library, and that's not good. If you've got contingencies inside your tech stack, and now they're pointing at non-existent libraries to run some Python code, you're going to have real problems. I mean, stuff is just not going to work, and we'll see more of that. We'll see more of this coming down the pike. It's really wild because the desire to use these systems is so powerful because they are so amazing, but you got to watch out for putting things in production. We're going to talk more with the folks from Data Squared and Neo4j and lots of others in the coming months, but don't touch that dial. We're listening. Listen to me. You're listening to DM Radio. All right, folks, back here on DM Radio, your host, Eric Kavanagh. Fascinating conversation today with David Linthicum, an industry analyst who, as I've mentioned, has built tremendous systems. He's a teacher, he's a doer, he gets things done out there. And we're talking about agentic AI and, of course, LLMs. And really the disconnect, or let's call it an impedance mismatch between deterministic systems and probabilistic systems. And this is, I promise you, the cornerstone of Gen AI, of these large language models. They are probabilistic in nature. All the other systems that we've used over the years, well, almost all, have been deterministic. In other words, you get a right answer. There is a right answer and a wrong answer, and that is gleaned from the data that was persisted in the database. In this field, column A, row 32, what is the information in there? You get it back, you use it. That's what you do with databases. At scale, you try to do formulae, you try to aggregate things and understand what's really happening in the organization. But again, deterministic. Now, we know garbage in, garbage out. That'll never change. Although it's worse now with AI. If you put garbage into an AI model, you're going to get uh, uh, severe garbage out. You're going to get toxic, disgusting, really nasty garbage on the other side. And you got to be careful about that. But you know, as we sort of grapple with these powerful engines, which are so powerful that you can't not use them. I mean, that's the bottom line, really. And we're starting to see CEOs say this. I know that Steve Lucas at Boomi said this about a year ago. He said that his people will be using Gen AI. He said you need to use it some way, shape, or form in your environment to start playing around with it. It's a new tool. It's a very powerful tool, especially for researching. But just to have some fun here, to finish off our show for the day, I went to ChatGPT 4.0. I asked it, please give me 7 bullet points to discuss about the fusion of Gen AI and traditional deterministic information systems. And so here are some of the things that it said: bridging probabilistic and deterministic logic. So Gen AI introduces probabilistic reasoning. That's what we're talking about. And remember, it's probabilistic because you're converting text or imagery into vectors and then converting those vectors back to text or imagery. This is a lossy process. It's generative by nature. So remember, it's not designed to give you the same exact data that you put into it. It doesn't work that way. It's a different system. It is more like the human brain and how we remember things and how we process information. And trust me, ever since I did the math on this, I have not stopped thinking about how my brain works and how I capture information, how I make inferences, how I align concepts in my head, how I deduct, how I do reasoning. All these things are being done in your brain. It's really quite fascinating stuff if you get right down to it. So, probabilistic. So, here's what they say: Gen AI introduces probabilistic reasoning and fluid natural language into environments traditionally governed by strict rules and structured data. There are still rules-based systems. They'll be everywhere. We talked about anti-money laundering last week, and you can have rules-based systems, but they're very rigid, and they wind up generating tons and tons of false alerts or false positives, if you will. That winds up being a pain to deal with. And as David even mentioned, yeah, sometimes these things are wrong, but as long as you manage that error rate, you should be okay. It's just a question of how you piece these things together. So use the LLMs for idea generation. Use them to kind of tease your brain, to give you something to think about. But remember, the deterministic systems are the ones that have the actual hard data. So the next thing it came up with was from CRUD to copilots. So CRUD, of course, create, read, update, delete operations. That's what information systems have done for decades, ever since we started them. Frankly, you create some data, you read it for an application, you update it when need be, and you delete it when its life cycle is over. Again, Copilot's very different from that. Copilots are your little buddy. They're a little research agent, and they are very, very powerful. They give you lots of ideas, but make sure you remain the human in the loop. Semantic interfaces. So Gen AI provides a natural language front end to deterministic systems like ERPs and CRMs. It's also great for training, for learning about how to use systems. Ask it about any number of things. Ask it about the basics of an ERP or a CRM. Ask it about IoT. All these topics have been published about widely, and so the LLMs will be pretty good at describing roughly how they work. Contextualization at scale. I mean, this is where you're starting to see some really exciting things happen. Think for customer service, for example. Think of it in a call center, you could, for example, pull data from a deterministic system like a customer records database. When that phone number rings in, ping the system, okay, this is John Doe. You can use an LLM to scan various information systems and give you an answer back about what they might be calling about. Even once they're on the phone and ask you a question, you could have a real time engine kind of listening and translating that, transcribing it, and then pinging the system, the LLM, to get some information about what to do. And that it's nice because the human can still decide whether or not to use that information. The human should be able to figure out, hey, was this a good recommendation or a bad recommendation from the engine? And the human can then take the action. This is why they talk about human in the loop. Very, very, very important. So that's contextualization, knowing all about this person as they dial in. Integrity meets imagination. This is an interesting one. Traditional systems are designed to be accurate, to ensure compliance, to be auditable. What does Gen AI do? It brings adaptive creativity and conversational capability, but you have to carefully govern these things. Watch out for the hallucinations. They do hallucinate. They will hallucinate. It's a feature, not a bug. Here's an interesting one, the middleware of meaning. I like this one. Gen AI acts as a semantic middleware layer. This is a good description, translating human intent into system calls and reformatting data outputs into human understandable insights. Folks, you could take any kind of data and throw it into one of these large language models, and you'll be surprised how good it can get. You could take machine data. You could take JSON structures, for example, take a big chunk of JSON, throw it at the LLM, ask it, what's this thing doing? You'd be surprised how accurate it can be. Now, sometimes it'll get it wrong, but you can learn about things. It can code. It can teach you about code. It can teach you about how computer chips work. I mean, it's really crazy. One of the straws on the wind that I've seen is Stack Overflow, which saw its traffic drop by 50%. Folks, for an organization that relies on web traffic, to lose half of their traffic in a fairly short period of time, that's a game changer. I mean, it's a death knell. It's a death spiral. So now apparently they're working on their own. Maybe they'll figure it out in time. It's hard to say, and it's going to be very difficult, I think, going forward for traditional media companies to withstand the pressure. I mean, these large language models, they're crazy. They're so powerful. And as we get better about building out RAG models, retrieval augmented generation, especially in conjunction with knowledge graphs, they're going to get much, much better at lowering, minimizing the hallucinations, maintaining accuracy and integrity. And then guess what? Why do I need a journalist to go talk to someone at XYZ Corporation if their data is public and I could just grab it and throw it on an LLM to ask it questions? This, I think, is the future of journalism, quite frankly, is interactivity, having little agents that are your reporters, your dynamic research assistants that are pinging information systems and giving you answers about things. And as long as the data is available to ping, think consumer purchasing information. You're starting to see more and more open data sets out there. This is going to be an incredibly inventive and exciting time for people who figure out how to use these things responsibly. That gets us to the next thing that ChatGPT said, governance and guardrails. Well, here's the rub, folks. How you govern these things, how you shepherd these things, how you tame the shrew, if you will, of LLMs, that's where the magic is going to be. And you have to be very careful about that because the little sneaky mistakes will creep in there and they will be significant. You'll think that the number is 40 when it's actually 4,000. I mean, these are the kinds of things that can happen. So be very, very careful. And you're going to see a lot of this hybrid search coming into play where you ask the LLM a question and then you have systems that then check the answer. The company called Victara is doing something like this just to see. It's like, okay, that was the input. Here was what the output was. Does that look accurate? I'm looking at the information, says the AI model, and it goes, maybe not. Try again. Go back and say, reply hazy, try again. Remember the magic 8 ball? I thought to myself that the Magic 8 Ball is great for fun, but don't use it for major life decisions. You know, same thing for LLMs. Use it for research, use it for understanding things, but be very careful about basing your corporate decision making on something the LLM told you, because maybe it's right, maybe it's not. We're going to be able to get closer and closer, I think, if we get these architectures right. And that's going to be excellent news for all of us, quite frankly. But folks, buckle up, man. Big things are happening. Jobs are changing quickly. AI is disrupting basically every corner of the business world right now. And watch out. It's coming. Send me an email if you want to be in the show. Info@dmradio.biz. You've been listening to DM Radio.